In this video, we are going to be doing 8 different examples of solving trig equations. So whether it says solve for theta, solve for x, solve for y, it doesn't matter. It depends on the symbol that they use to represent the missing angle that we are looking for. Now, I made every single example slightly different, and we're going to work through this mindfully because we are not trying to memorize sums. We are trying to understand so that you will be able to solve this on your own when your questions look slightly different. Okay, let's jump in and look at number 1. It says that we need to find sine theta when it is equal to 0.5. Straightforward, nothing funny. If you know how to use your calculator, you are good. We need to let the calculator know that we're not giving it an angle, but a ratio of sides. So we need to say shift sine 0.5, and then we get that that angle theta is equal to 30 degrees. How can we check our answer and see if it's correct? Well, if we put into the calculator sine and angle 30, it needs to give us 0.5 or a half, and it works. Second example. Okay, so this one, it says a half times sine theta is equal to that 0.438. Okay, we need to find theta. Now, before we can put this into our calculators, we need to isolate our trig ratio. So we need to get rid of anything that is being multiplied or divided by it. So we need to ask ourselves with this one, grade 10, how are we going to get rid of that fraction that is in front? Not just one way of looking at it. We can say that we are going to divide this side by a half, because when we do, then they cancel out and we are left just with sine theta on the left. But as long as you do the same thing on the right-hand side, right? So then we've got 0.438 that we are dividing by half, and that gives us 0.876. Now, however you decided to solve that equation, as long as you get to that same answer. And now, straightforward, we need to find that angle. So into our calculators, shift sine 0.876, and that gives me, in this case, that theta is equal to 61, and if I round that off to 2 decimal places, it would be that, and that would be degrees. Okay, next up, we need to solve for theta. There it is. Okay, but now we need to be careful because cos theta is being multiplied by 3 there, and then we are subtracting 4. Okay, well, we need to isolate our trig ratio before we can use our calculator to find that missing angle. So just like solving an equation, it's like this. It's when you've got 3x minus 4 is equal to -3. We need to look at it like that, where we need to isolate that x in order to solve it. So with this, we're just going to isolate our trig ratio. So when we do that, we need to plus 4 on this side to make it go away, just as long as I do it on the other side as well. Some of you would say that I'm taking the 4 over and change the sign, but actually that is what is happening. And that would give us just 1. And again, we need to isolate our trig ratio. And that means that we need to divide both sides by 3. When we do that, we get that that is a third. Perfect. We isolated the trig ratio. Now we can just use our calculators to solve for theta. Into our calculators, shift cos, and then the ratio of sides, 1/3, and that gives us that. In this case, theta is equal to 70,53 degrees, rounded off to 2 decimal places. Note, just this is important, if it was 3 cos and then in brackets theta minus 4, that is something else. Then it means that this 4 is part of the angle, and we will get to an example on how we deal with that. But in this case, it wasn't in brackets, so we can take it over to the other side. All right, number 4. With this one, we've got cos 3 theta. It's part of the angle is equal to that. Now, please don't do this. Please don't say that it's cos 3 theta and then we divide it by 3 and then those cancel. We can't do that. Please don't do that. It is part of the angle. We can't just go and chop the angle in 3 pieces like that. The angle stays together. Remember, if you tell your calculator now, shift cos and the ratio of side, it spits out the whole angle for you. So let's just do that. Shift cos, the trig ratio is isolated, even though the angle has more than a theta going on over there. So shift cos 0.649, and that gives us equal to, so the whole angle for that ratio is that. But the whole angle is just represented by 3 theta. There's my whole angle. So therefore, to get theta by itself, we just divide that by 3. We divide both sides by 3, and then theta is 16,51 degrees. How can we test if this works? Grade 10, so we can say cos, and then we can say 3 times that, which just gives us that whole angle. And if we put it into the calculator, it will give us that ratio of sides. Very important. Number 5, what is our goal? We first need to isolate our trig ratio, get it by itself before we can use our calculator to solve for theta there. So we need to get rid of that 3. So tan theta is being divided by that 3. So what we can do, let me just write this over. What we can do is we can just multiply this side by 3. Why am I multiplying by 3? Because then these cancel out. As long as I do the same thing on the other side, I can do that. So now I got rid of the fraction by multiplying with whatever the denominator is, and then I get 0.74, and I times that by 3, and that gives me 2,22. All right, and now we use our calculators to solve for theta. Into the calculator, shift tan 2,22, and that gives me my angle. My angle is 65,75, and you can obviously check whether that works when we substitute that back in there. Number 6. Okay, we spoke about this earlier. That 60 is 60 degrees. It is part of the angle. It is part of the angle. You cannot say, I'm going to subtract 60 on the other side. It's an angle. This is a ratio of sides. We're not going to put them together. That is part of the whole angle. So let's just put into our calculators, shift tan, and then we give it the ratio of sides, 2.5. Then the calculator will spit out the angle for us. So the angle for that is 68,2 degrees, rounded off, but then that represents the whole angle in this case. And then we just have to take the 60 over. Now we've got theta is equal to 68.2, subtract the 60, and that would be, we really didn't need our calculators for that one, 8.2 degrees, and that is the size of theta. Now do you see when we plug that in there, we get to 68,2, and then when you put into your calculator tan 68.2, it does give you 2.5. All right, so take note, with the angle, we leave it alone. Number 7, let's just investigate to see what's going on over there. Okay, we need to keep that together. It's part of the angle. We'll solve that towards the end, but we do need to get rid of that because remember our aim is to isolate our trig ratio together with its angle. The sign without an angle means absolutely nothing. Okay, so let's subtract 2 on this side because it will make that go away, and then I just subtract 2 on that side, just equation knowledge again. So now we are this far, sine theta take away 20 degrees is equal to, so 1.2 and I subtract 2, that would give me negative 0.8. And now into our calculators, we keep that together, don't take the 20 over, it is degrees, it belongs with the angle, it is in brackets. Let's put it into the calculator, shift sine, because we are letting the calculator know that we are putting it in a ratio of sides. Therefore, our angle sine minus 20 is equal to minus 53 or negative 53.13 degrees. And now we can plus 20 this side to get theta by itself, and plus theta that side. Theta is then equal to that plus 20, which gives us negative 33. Now we're like, okay, but wait a minute. First of all, this is a negative angle. How does that even work? Because we are measuring this, it needs to be positive. And then also, this is not within the restriction that we were given in the beginning, that theta needs to be between 0 and 90. So what does this mean? Can I ask you for now just to accept this as is? For now, we're just going to have to accept this as is. As you plug this answer into your original equation, you're going to see that it actually works. And we'll talk about that. You can head over to the video on dealing with the cos diagram or the Cartesian plane, where we're going to make sense of this idea of a negative angle and what that means. So make sure that you check that out. Next one, last one. We need to isolate our trig ratio. There it is. Let's see what's going on. We'll have to get rid of that 5 in front that's being multiplied by it. And then that is our angle. It's 2 times theta. We're not going to separate that now. We can't just go and divide that by 2 on both sides. It is the angle. The angle stays together. So let's go divide by 5 on this side, then that happens as long as we do the same thing on the other side. So then we are left with cos 2 theta and 0.83, and I'm dividing that by 5. That gives me 0.166. Let's put this into our calculator. We just tell the calculator shift cos 0.166, and then the calculator spits out that whole angle for us. This whole angle is equal to 80,44 degrees, the whole angle. And then we divide it by 2 to get what theta is. And there we go. Since this is fresh in your memory, I would say go and try some of these trig equations on your own.